Picking up where we left off in the last video, I want to go ahead and move on from the Isimple plus emitter to the Isimple plus volume. So I'm going to go ahead and double click that to assign that to these surfaces. You're going to see that we start with the metallicity, the base color, and the roughness, just like we saw before. And if you come down a little bit lower, you can see that there's the normal map. And the way I designed this is I try to make sure that these guys were all within a setting where you didn't have to scroll if you didn't need to, so that you can keep your scrolling to a minimum and speed up your workflow. Now that said, what I want to talk about that makes this particular one different is the idea of volume, which is the reason why this one is named volume. Now the first thing that you need to understand about applying this particular shader is the idea that the surface that you're applying the shader to needs to be solid. It needs to be watertight. There can be no holes, because any place that there's a hole is going to create problems with the rendering of the volume. The reason why is because when the light ray comes in, it comes in with a particular normal for that light ray, and as it hits the surfaces, it's going to be bent, and then as it goes out the other side, it's going to be bent again. This is a process called refraction, and the idea of that refraction is that if there's a hole somewhere in that geometry, then that's going to be broken. So we definitely want to make sure that when you're using the Isimple plus volume, that the geometry that you're applying it to is watertight with no holes. This cannot be applied to a single polygon type surface, and generally speaking, I would even avoid using it on things like figures for a couple of different reasons, not the least of which is that refraction tends to be a fairly expensive calculation for render engines, and so it's not really something that you necessarily want to use for figures, although there's times when that may be appropriate depending upon the type of figure, maybe if it's ice or water or something like that. So let's go ahead and talk about what makes this one special. So if you remember, we have the metallicity and we have the base color. And down here, we have our refraction weight. Now, right now, it's currently set to a refraction weight of 1, which means that this is going to be something that's transparent. The idea of the refraction weight is we could map this, and so we could say that we want certain parts of this object to be transparent and other parts to either be the base color or metallicity, depending on what you want. It's important to know that the metallicity always overrides everything else. So if anything is set to be metallic, then even if it's set for a refraction weight, it's going to be metallic. Metallicity always overrides everything else. Now that said, once we have some sort of refraction in our object, the next thing that we want to be concerned about is the refractive index. Now currently the default is going to be a refractive index of 1.5. Now for typical glass objects, it would be 1.51. For a plexiglass type of acrylic, it would be 1.491. For seawater, it would be 1.35. And for freshwater, it would be 1.33. And if you wanted to make this air, meaning that it would be the exact same thing as the air that you're seeing in your renders, then it would be a value of 1, because inside of DAZ Studio and iRay, there is no air. So what we're seeing as air is actually vacuum. Now, if you wanted to go ahead and create something like, say, a fog effect using this, then you would set the refractive index to 1, and then you would begin to set your subsurface scattering properties that you see over here. But we'll talk about that in just one second. The next thing that we want to be concerned with once we have set our refractive index to be whatever is appropriate is the ABBA value. Now, the idea of the ABBA value is that at 0, we're not going to see any dispersion. Dispersion is what happens when you are looking at a light being shined through a prism and it breaks apart into its components, meaning the rainbow. So at 0, we're not going to see the rainbow. However, at any value higher than 0, we're going to see the rainbow. Now, what's kind of counterintuitive about this is that typically speaking, the ABBA value starts at around, say, 60. That's when we begin to see dispersion. And then as you decrease the ABBA value down to lower values, it's going to become stronger and stronger. So at 0, we're not going to see any. But typically speaking, then we would want to go to 60 and reduce down until we're getting the level of strength of the dispersion effect that we want to see. Now that said, it's important to note that dispersion is extremely, extremely render intensive. So you don't want to use it unless you absolutely need it. Now below that, we have the transmitted distance, and this is very important. Now I have a value here of 5. So what that basically means is that this is going to be going a distance of 5 units of measurement through this object before half of the intensity of that light is absorbed by this color. We can see this by coming over here and doing a render real quick. So I'm just going to render this. And what I want you to see is that we're going to be seeing something that's kind of like a slightly dark version of this color right here. And the reason why is because the transmitted distance is 5. I'm going to hit cancel. And I'm going to say yes because I want to cancel that. I'm just going to go ahead and move this guy over. And I don't know why it doesn't want to stay that first time. And then I'm going to come over here and I'm going to set the transmitted distance to 10. So I've doubled the transmitted distance. Now the light's going to be able to penetrate twice as far through this surface before half of its value is absorbed by this color. So if I render, you're going to see that we get a lighter blue. So the transmitted distance is going to be something that's very closely tied to the base color. You set the base color to be whatever color you want. You set the transmitted distance to be the level of absorption of that color through the surface. And again, this is going to be relative to the thickness of the surface. I'm going to hit cancel, say yes, and we're just going to compare the before and after so you can see how much that transmitted distance impacts the darkness of that. Because again, more light is being absorbed through a shorter distance in this particular object, whereas less light is being absorbed as it's going through the same distance here. So the distance is very, very important in terms of the color that you get from anything that has a refractive value higher than 0. So then we need to talk about the scattering distance. And the idea of the scattering distance is that this is going to be relative to the SSS amount in the same way that the transmitted distance is relative to the base color. The important thing to know is that the SSS amount cannot go higher than a value of 1. So we want to modify the scattering distance in order to make this SSS amount more obvious if it's not strong enough. So I'm just going to come over here and set it all the way to 1. We're going to come over here and we're going to render this. So at a value of scattering distance of 1 and an SSS amount of 1, we're going to see a fairly opaque object. Now, if we wanted this to be more transparent, what we could do is reduce the SSS amount, or we could increase the scattering distance, either one. If we wanted this to be more opaque, more of the subsurface scattering going on, we can't increase the SSS amount. So what we would do instead is we would come over here, and I'll just move this off to the side. And I don't know why it doesn't want to take the first time. And then I'm going to come over here, and I'm going to go ahead and set this value to 0.5 instead of 1. So basically what this is going to do is it's going to double the SSS amount because it's halved the distance. So I'm going to go ahead and render this now. And you're going to see that this is much more dense or opaque as a result of that lower scattering distance. And so the idea here is that these two parameters work together in the exact same way that the transmitted distance and the base color work together. So that's that. I'm just going to go ahead and hit cancel and say yes. And then I'm going to come over here and compare, and you can see that this one is more transparent. This one is more opaque as a result of the fact that we reduced the scattering distance in order to make the subsurface scattering amount value of 1 to become stronger because it's being measured over a shorter distance. So I'm going to go ahead and close those two. And then finally, we have the SSS direction. Now, the idea of this is that if we have a light ray coming into this volume, and we want that light ray to continue on going through the volume, then we would go ahead and we would set this to be a positive anisotropy, or that's basically what's going on here, is that the light is going to scatter positively through the surface. If we wanted the light to scatter back towards our eye as the direction of the light, then what we would do is we would set this to a negative value, meaning that as the light rays were penetrating into that surface, they were going to be bouncing back in the direction that the light originally came from, and very often where we'd be seeing this is from our own vantage point. So the idea here is that if we set this to negative, it's going to appear to be more opaque. And if we set it to a positive, it's going to appear to be more transparent. Now, typically speaking, you would want to leave this at a value of 0 unless you have a particular reason for changing it to either positive or negative. Now, that said, that's basically all there is to know about this Isimple Plus volume. So we're going to look at the final type of Isimple shader in the next video.